Where does the line end?
Okay, so I'm going to continue on with ionic compounds and focusing on polyatomic ions in this lesson. So polyatomic ions, we have briefly covered polyatomic ions in chapter 6 when we did Lewis structures. These were the guys, or the structures where you had to draw them out and then you had to put it in a little bracket and then indicate the charge. So poly means many, atomic means atoms, many atoms, and they kind of act like a unit by itself. They have covalent properties as well as ionic properties because they usually have a charge, but they're held together by covalent bonds. So any polyatomic ion that contains oxygen, we call it an oxyanion. Wow, oxyanion. And they usually use prefixes or suffixes to indicate how much oxygen it has. Am I going to quiz you on this? No. No. Because if you were to ask me, Mrs. Erickson, which one has more oxygen, sulfate or sulfite? I'm going to take a guess. Like I'll probably say, oh, I don't know, 8, so which it is, but still. I usually have to guess, okay? And I usually guess correctly, but so hypo just means one less oxygen than ite, and then B and C are the opposites of each other, but ite has less oxygen than 8, and then prefix per just means, hey, there's more oxygen in that one, right? Okay, so all you got to know is if you see these prefixes, oh, there's going to be oxygen in that polyatomic ion. That's all you need to know from this slide. Sorry, that was probably really loud. Okay. So in your book, and I better double check, make sure this is the right page number, there's a table of polyatomic ions because you can't find them on the periodic table.
Oh, this is the cheat sheet.
Yeah,
That's awesome, actually.
Ah, excellent. Yes, figure 1.3 on page 220 has pretty much all the polyatomic. It says some polyatomic ions. So I'm sure it doesn't have all of them, but this right here also has lots of polyatomics with their charges. So I'm gonna zoom in just a little bit here. So one type of polyatomic, ammonium, we have nitrogen and 4 hydrogens, and it's got an overall +1 charge. When we drew the Lewis structure, it was like a tetrahedral. Okay, here's acetates. You're going to see a lot of acetates the next couple of days. So it's the CH3-CHU or the CHU. Yeah. No? Okay. I think we had Kiara. Yeah, I had Kiara last year, so we were like, oh, it's the CHU one. Yeah, okay. But yeah, so these are just some examples of polyatomic with their overall charges. All right, table just, hey, there's your IDE, that's our typical end of an anion. And then we have our 8 and our ite. Some more prefixes that you probably know. Mono means 1, di means 2. And if you see thio, that means instead of an oxygen, it's been replaced by a sulfur. It's got sulfur in it. But am I going to quiz you on that? Probably not. I mean, yeah, I'll double check, but I don't think I have anything. Okay, so how do we name polyatomic ions? Very, very similar to the binary ionic compounds, which is nice. So with our regular ionic compounds, the first name is your cation, and you usually just name it. So if you had sodium bonded to a chlorine, you just said sodium. But if the first part of your chemical formula is polyatomic, maybe it's ammonium chloride, then you just use the polyatomic name as is. Okay, the second name, remember with our anion, we switched it to IDE. Well, if the second name is polyatomic, just use the polyatomic name. Do not change the ending on it, just state the polyatomic name. Any questions with that? We'll have some practice, and then when we do the assignment, we'll do some of them together just to make sure that. Okay, so here we got an example here. It says, write the formula for iron 3 chromate. So you're like, all right, I'm going to get my pen out here. So iron's got this +3. And then chromate. And you're like looking on the periodic table and you're like, oh, I see chromium. Is chromate chromium? No. No. You're going to be sitting there searching for it for hours. Chromate's not on the periodic table because it's polyatomic. Okay, so I'm going to go back to my polyatomic here. Chromate.
It's on the second line.
Thank you. There it is, right here. So it's CrO4, and it's got a -2 charge. CrO4 with a -2 charge. So, okay, so I'm just going to make a little note here. CrO4 -2 charge. Okay, so it's got a -2 charge. Well, my charges don't, they're not equal. So how many irons am I going to need? 2. All right, so I'm going to take this times 2. So I got Fe2. And then chromate is CrO4. And it's got a -2, and I got to get to a 6. So how many times do I got to multiply chromate to get to 6? 3. So to show that, you actually have to stick, you got to stick it, you got to stick parentheses. This is a polyatomic ion, and I want to show, hey, you got to multiply everything inside the parenthesis by 3.
Okay. Sure,
Too far. Don't remember.
Too far, don't remember.
Too complicated.
Okay. How do we feel about that one?
Good.
Okay.
Sure.
Sure. Okay.
You start adding math to the letters. I could Google this stuff.
like algebra.
Like once you start dealing with cations and stuff, I can't.
All right. Down here, we got to name the compound. So I'm going to switch back here.
Potassium.
So we got K2CO3. So you might start, oh, potassium carbonate oxide. Ugh, that doesn't sound right. That's not binary. Okay, binary is first name, last name. So CO3
Is a compound.
is a polyatomic.
It's carbonated.
All right, so I'm going to type in potassium because I know K is potassium. And then CO3, geez, I got to figure out what CO3 is.
Carbonate. On the top, right above carbonate.
Oh, yeah, there it is, right there. There's carbonate.
-2
-2
charge.
charge.
So potassium carbonate.
Yep, potassium carbonate.
That's the compound.
That's
Now,
how many opposites
because
are
it's
there.
polyatomic, I just use the polyatomic name. I'm not changing the ending on that. Just use, if it's polyatomic, you just use its name. So yes, this should work out because the formula's already been done. Right, so overall +2, overall -2, it's neutral potassium carbonate. All right, we got some more, right?
What's
Cyanide.
Okay, write the formula. So calcium, Ca +2, and then cyanide.
That is right up.
Oh, Cn negative.
Cyanide, CN negative, yeah.
Yeah, you're right. It's polyatomic. You're not going to find cyanide on the periodic table.
In all
So my suggestion is just check to see if it's not familiar. Obviously, just check the polyatomic table before you start searching all over the periodic table for it. So cyanide, I believe, is a -1 charge,
Yeah.
and it is Cn, just straight up Cn. Okay. So when I write the formula, I got my calcium.
Put CN for
Right, it's got a +2. Cyanide's -1, so how many cyanides am I going to need? 2. So I write,
those in parentheses.
yeah, you got to put it in parentheses. So I need 2 cyanides, so I'm going to stick it in parentheses with the little 2.
Equals 0.
Yes.
After you're doing one.
It's carbon and nitrogen. It's the triple bond, if I'm not mistaken.
It's pretty simple.
Okay, calcium acetate,
So we want like
Acetate, that's
CH3Q,
Yeah.
right? Okay.
Oh, it's the first one.
The CH3 it's -1.
Okay, so acetates is my CH3,
Calcium is
COO, it's my chaku. God, I really really wish Kiara was here for this. And I believe it's a -1 charge, but I should probably double check myself. Check myself before I wreck it. Wreck myself. Okay. Yep. Okay, so you'll notice, yep, there it is. So there it is, CH3COO, the -1 charge. All right, +2, -1 charge. How many acetates am I going to need? 2. So I'm just going to put my parentheses. CH. Good question. Valid question. You could put the 2 down there. I'm not going to mark it wrong. I'm not going to mark it wrong. You'll see acetate in different forms, like simplified. So, yeah, I've seen it that way too.
Ammonium's
Yep.
NH4.
Would the -1 have to be in there, like in the parentheses?
Nope, you don't need to indicate the charges in the formula.
So that's the charge.
Yep, this -1 is the charge. Language, Levi. I'm videotaping.
Sulfate is -2. So this is 2.
All right, ammonium. Yeah, you're scanning the periodic table. You're not going to find it there. Okay. Ammonium is a polyatomic. It's NH4 with a +1. Sulfates. Sulfates. Polyatomic.
We have to polyatomic.
Sulfates.
Oh.
Polyatomic. There it is. SO4 with a -2.
Is it 4 so it equals out.
So it's just like NH.
SO4 with a -2.
I think.
Yes, we need 2 ammoniums. So I'm going to put NH4.
Do we put the SO4 parentheses even though it doesn't?
Nope.
Okay.
Nope. Only the ones that you need multiples of. And it's only for the polyatomic. So NH4, I need 2 of them. And then it's SO4 by itself.
I believe we had that for this.
Yeah. Yeah.
Alright, and it's almost 40 degrees out.
Yeah, it's nice out there.
What?
Good, because I have to walk to work today.
I'd say, what is it? I think like 34 today, right now.
Okay.
My phone says it's 39.
All right, so your assignment is to finish the assignment from yesterday and
Okay.
bring your questions.
Okay.